Welcome back to MPB's Boot Camp for Algebra 1. I'm so glad that you came back today. We are looking at our Lesson 3, Inequalities, and these are our standards that deal with these inequalities. So let's go ahead and jump in. We need to remember what inequalities mean. We have our inequality system. What does not equal? What is less than or equal to, greater than or equal to. So we want to make sure as we go through these MAAP questions that we remember what our inequalities mean. So here we go. The power of annotation helps. So we have the power of studying and the power of annotations. We are looking at Mississippi Department of Education test questions. So a school has 124 students who want to take a new computer class. Each class can have a maximum of 18 students. Which inequality could be used to determine how many classes C need to be scheduled so that all students can take the class? Okay, so now that I've looked at the question, let's go ahead and annotate some important information. A school has 124 students. They're all taking this class. I can have a maximum of 18 in each class. How many classes, or C, need to be scheduled? So I know that 18 can equal the amount in the class, or the ones in the class have to be less than that 18. Now, how to determine how many classes are going to have that amount of students? I take all the students that I'm going to have at the school and divide them by how many classes we need. So do I see that on my answers? Why, yes, I do. A would be my answer. So by me annotating the question, pulling out those keywords and phrases, writing down what I know of inequalities about maximum, about how many need to be, I can go ahead and make my answer and then just go to my answer choices and see which one means the same thing. Now, I said means the same thing instead of look like my answer, because remember, when I'm reading these inequalities, this means the same thing as this. So you want to make sure that X equals or is bigger than 18 equals or is bigger than how many can be in the class. So that's why I said means and not looks. Good job. Let's look at the next one. What is the solution to -2 times 9r plus 3 minus 7r, which is greater than or equal to -10r minus 12r plus 9? So what I'm doing is I'm finding my values when referencing of r. So let's go ahead and work this problem. So the first thing I'm going to do is distribute. So I have -18r minus 6 minus 7r, making sure I pull down that inequality sign. Now, Ms. Killen, I see parentheses, but I don't see anything in front of it. You see that subtraction, and there is obviously an understood 1 there. So I'm going to distribute that. -10r, -12r, minus 9. Now let's go ahead and put like terms together. -18 minus 7 is what? -25r minus 6. And then I put my -10r minus -12 would be -22r minus 9. I'm going to go ahead and put all of my variables on the left, so I'm going to add 22r to both sides, which I have -3r. I'm going to add 6 to both sides, which would be what? -3. I'm going to divide by a -3. When I divide by a negative, I have to flip my inequality symbol. Negative divided by a negative is a positive. Do I have an answer choice that means the same thing as r is less than or equal to 1? I have the exact r is less than or equal to 1. Good job with those opposite operations, getting that variable together. We want to make sure that we're doing the math correct. All right, let's look at the next one. Make sure you are reading the meanings of the inequalities and not just the points. We want to make sure that we're understanding why we're using these inequalities, not just looking at which way it's pointing. Inequalities. What is the solution to negative 7x plus 4 minus 5x, which is greater than or equal to negative 10x minus 2 times 3x plus 6? The first thing I'm going to do is distribute. I'm going to distribute this understood 1 right here into my inequality. So I have negative 7x minus 4 minus 5x greater than or equal to negative 10x. I'm going to distribute here as well. Negative 6x minus 12. Going to put like terms together. Negative 7x minus 5x is going to be a negative 12x minus 4. Put these two like terms together. Negative 16x minus 12. Let's put our variables on the left side by opposite operation, adding 16x to both sides. I have 4x. I'm going to add 4 to both sides, which would give me negative 8. I'm going to divide by a positive 4. When I divide by a positive, my inequality stays the same. So I have x is greater than or equal to negative 2. Now, do I have one that means the same? X is greater than or equal to negative 2. Good job. Make sure that your math is correct. Make sure when you divide by that positive, you are not switching. You keep it the same. Good job. So here we go. Let's look at the next one. How many solutions does the inequality have? So what I am going to do is I have no solutions, 1 solution, 2 solutions, or infinite many solutions. So let's plug this into Desmos. Let's see what our answer choices could be. So I'm going to pull up my Desmos, and I'm going to plug that in. So everyone plug yours in right along with me. So I have 2 times 2 plus 2. I can't use t, but I can use x. Close parentheses. Make sure you use the correct inequality symbol, less than or equal to 4 times, can't use t, but I can use x, minus 1, close parentheses. Now, Ms. Killen, I don't see anything. No, you don't. So let's maybe scroll out. I do not see anywhere. Okay, Ms. Killen, well, why? Well, let's go back and try to put y. Nope, I can't even put that. So what could I possibly say about this inequality? It does not have a solution. I can never make this inequality true. Never. So what could my answer choice be for this question? No solutions. It will never be true. This side will never be less than or equal to this side. Good job. And that's a good use of Desmos too. Literal equations. Mona sells supersized cakes for $1.50 each and estimates she will have expenses of $10 to make 1 batch of cakes. If the inequality 1.5c minus 10 is greater than or equal to y, models the situation. How many cakes C would she need to sell to make a profit of at least 30? So let's see. If I take 30 as my profit, at least, meaning I can make more but not less. So let's plug that into our inequality to see what we find out. 1.5c minus 10 has to be greater than or equal to our 30. So let's solve for our variable. So I'm adding 10 to both sides. I have 1.5c is greater than or equal to 40. Now, I want to show you something that Desmos will do. I have 1.5 that I need to divide here. Let's say that your calculator loses battery, and I need to make sure I get this fraction correct. I can pull Desmos up, and I can say 40 divided by 1.5, and it tells me 26.6 repeating. So I can use that as a calculator as well? Absolutely. So I can say C has to be greater than or equal to 26.6 repeating. Well, I can't make a part of a cake. It's just a smaller cake. So I would need to make 26 or more, so I would round this up to where my cakes made are greater or equal to 27. And that's how we work this problem with the decimal and using our Desmos as our calculator. So there is that feature on Desmos. Good job. Field trip time. A professional development trip is being planned for 205 teachers from Wilma Springs Middle School. The teachers will be traveling by bus, and each bus can hold a max of 45 teachers. Which inequality could be used to determine how many buses B will be required to transport all of the teachers on this professional development trip? So let's go back and annotate and see if we can solve for this. So we have 205 teachers. The max the bus can hold is 45. So I know 45 is the most it can be. 45 can be bigger or equal to the amount on the bus. Well, how do I figure out exactly how many buses? Let's see. I am going to take how many we have, which is 205, and divide it by how many of those buses we have. Do I have one that equals or means the same thing as we've written? Right there. Good job. That is how we annotate these problems and write an inequality. Good job. Shopping. Kinsey has $100 to spend on pants and belts. She buys a pair of pants for $75 and wants to spend the rest of her money on belts. Each belt costs $3.50. Let M represent the number of belts that Kinsey can buy. Which inequality represents her situation? So let's go ahead and annotate this problem. She has $100 to spend. Can she spend more money than she has? Well, technically no. So we can spend exactly 100 or we can spend less than 100. Now, what are we spending this on? Pants, which is $75, plus our belts. So we did $75 for the pants. Each belt costs $3.50 and M's our number. So I have $3.50 M. Do I have one that means what we have written? Let's see. 75 plus, here we go. And that's how we annotate and write that inequality. We want to make sure when we're annotating these problems, we're getting the important phrases that's going to help us write either our equations or our inequalities. Good job. I want to thank you for coming and working with us here at MPB in this boot camp. And as always, have a great day.